Hey everyone, and welcome. Today, we are diving deep into one of Python's most essential tools, the list. Seriously, in just the next few minutes, we're going to take you from zero to hero, and you'll be organizing your data like an absolute pro.
Have you ever had that feeling where you're just juggling a ton of different pieces of data? Imagine you're a teacher, right? And you're trying to track 30 different test scores. You could create 30 different variables, score 1, score 2, score 3. It would get so messy so fast. There has to be a better way, right?
Well, of course there is. This is exactly where the Python list shines. Instead of all that clutter, a list just groups all those related values into one single, neat container. The result? Your code is clean, it's efficient, and honestly, it's just so much easier to work with.
So here's our game plan for today. We're going to start with the why. Why lists are so important. Then we'll break down the anatomy of a list. We'll explore their cool ability to change on the fly, check out all the tools you can use with them, and then, to wrap it all up, we'll build a fun, practical example together.
Okay, first things first. Why should you even care about lists? Well, it all boils down to a really important idea in programming. Don't repeat yourself, or DRY for short. And lists, they are the ultimate tool for keeping your code DRY and your data perfectly organized.
So, what is a list, really? Think of it as an ordered collection. And ordered is key here. It means every item has its own specific spot. It's also changeable, which means you can modify it anytime you want. And maybe the best part, you can mix and match anything you want in there. Numbers, words, you can even put other lists inside of a list. All right, so we know what a list is, but how do we actually get stuff out of it? That's what this next part is all about. Accessing the exact piece of data you need right when you need it.
Now, here is probably the single most important rule you need to burn into your brain about lists in Python, and, well, a lot of other languages too. Counting always starts at 0. So the very first item is at position 0, the second is at position 1, and so on. I know, it feels a little weird at first, but trust me, you'll get the hang of it in no time.
You can really think of it like this table. Each index is like a pointer to an element. So if you want the P, you ask for index 0. If you want the T, you ask for index 2. Simple enough? But check this out, because this is really cool. Python also lets you count from the back. The index -1 will always give you the very last item. -2 gets you the second to last, and so on. It's an incredibly useful shortcut.
This brings us to one of the superpowers of lists. They are mutable. Now, I know that's a fancy word, but all it really means is that they can be changed after you create them. This flexibility is what makes them so powerful for handling data that's always in flux. So let's just imagine we have this super simple list right here. We'll call it numbers. It's got 2 items in it, 17 at index 0 and 123 at index 1.
Now watch this. We can directly target an element using its index and just give it a new value. Here, we're basically saying, hey Python, go to index 1 and replace whatever is there with the number 5. And just like that, the list is updated. The really crucial thing here is that we didn't have to create a brand new list. We modified the original one right where it stood.
Okay, so you know what lists are, you know how to change them. Let's get to the fun part, the toolkit. These are the built-in functions and methods you'll be using all the time to work with your lists.
First up are the functions. Think of these as your general-purpose helpers that give you quick info about your list. You can instantly find out how many items are in it with len, or if you're working with numbers, you can find the sum, the max, or the min value in a snap.
Next up, we have methods. Now, these are a little different. Unlike functions, methods are actions that belong to the list itself. You call them using that little dot, like mylist.append, to do things to your list, like adding items, removing them, or sorting the whole thing.
Let's see one of these methods in action. It makes it so much clearer. So we start with this list T that has A, B, and C. Then we call T.append D. And what does Python do? It just tacks D right onto the very end. This is by far the most common way you'll be adding items to a list.
All right, theory is great and all, but let's make this stuff real. In our final section, we're going to pull together everything we've just learned, creating a list, adding items to it, and sorting it, and build one practical, interactive example. So, what are we going to build? We are going to make a simple but really effective program, an interactive shopping list. It's the perfect way to see how lists can be used to grab input from a user and organize it on the fly. So the program kicks off with a completely empty list, nothing in it. It then asks the user, enter an item. The user types milk.
Hit Center, and our code uses that .append method we just talked about to add milk right into our list. See? Simple as that. And the program doesn't stop there. It just keeps asking for more input. This time, the user enters bread. And what happens? You guessed it. Append does its job again, adding the new item to the end of the list. You can literally see our list growing, one item at a time.
Finally, the user types Done to signal that they're finished. The program stops asking for items. But before it prints the final list, we call one more powerful method, .sort. And bam! This instantly reorganizes the entire list alphabetically. So what we get is a nice, clean, organized shopping list.
So let's do a super quick recap of what just happened. We started from scratch with a totally empty list. We used a loop to keep asking the user for items. Inside that loop, .append was our workhorse. It did all the heavy lifting of adding items. And at the very end, .sort came in for that final polished result. You just saw the entire life cycle of a list in action.
So remember, lists aren't just for storing data. They're an absolutely fundamental building block for creating interesting, dynamic, and powerful programs. You could use them for a to-do list, for keeping player scores in a game, for scientific data. The possibilities are endless. The only question left is, what are you going to build?